This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 6, Helical, Bevel, and Worm Gears. Lesson 5 loaded a spur tooth in a single plane, a tangential load from power, a radial load from the pressure angle. Now we tilt or turn the teeth, and a third direction appears, an axial thrust. Helical gears add it with a helix angle, bevel gears with a pitch cone, and the worm drive trains a huge single-stage ratio for real friction losses. The theme of the whole lesson: every new axial force lands on the bearings we sized in Lesson 2. Concept: why go beyond spur? A straight spur tooth keeps its load in one plane, a tangential force and a radial force. Angle or turn the teeth, and a third component appears, an axial thrust. Helical teeth ride on a helix angle, which makes them quieter and engage gradually, but they push sideways along the shaft. Bevel gears turn the drive through a right angle and carry both an axial and a radial component, and the worm drive gives a huge single-stage ratio with heavy sliding friction. In every case, the tangential load still comes from power, just like Lesson 5, but the new axial force becomes the thrust term in the bearing equivalent load from Lesson 2. Miss it, and the bearing is undersized. Helical gears, Part 1, 2 planes. Unwrap the pitch cylinder and the tooth runs across it at the helix angle. Every pitch measured in the plane of rotation, the transverse plane, has a smaller partner measured across the tooth, the normal plane. The normal circular pitch is the transverse pitch times the cosine of the helix angle. The axial pitch is the transverse pitch over the tangent of the helix angle. The normal diametral pitch is the transverse one over the cosine. And the pressure angles differ too. The cosine of the helix angle equals the tangent of the normal pressure angle over the tangent of the transverse one. The catch for later: cutters are defined in the normal plane, but the force triangle lives in the transverse plane. Helical gears, Part 2, the 3 forces. The total tooth force acts in the pitch plane and splits 3 ways. Radial is the total force times the sine of the normal pressure angle. Tangential is the total times the cosine of the normal pressure angle times the cosine of the helix angle. And axial is the total times the cosine of the normal pressure angle times the sine of the helix angle. But you rarely start from the total. You start from the tangential load, which power gives you. So, invert. The radial force is the tangential times the tangent of the transverse pressure angle. The axial thrust is the tangential times the tangent of the helix angle. And the total force is the tangential over the product of the 2 cosines. Notice, the axial thrust is set by the helix angle alone. Helical gears, Part 3. Solve for the thrust. Given a tangential load of 1,000, a normal pressure angle of 20 degrees, and a helix angle of 30 degrees. First, the transverse pressure angle. Tangent of the transverse angle is the tangent of the normal over the cosine of the helix, giving about 23 degrees. The radial force uses that transverse angle. Tangential times its tangent, about 420. The axial thrust is the tangential times the tangent of the helix angle, 577. And the total normal force is the tangential over the 2 cosides, about 1230. That 577-pound thrust is the axial load you carry into the bearing equivalent load from Lesson 2. A spur gear at the same tangential load would give the bearing no thrust at all. Bevel gears, the right angle drive. Bevel teeth sit on a pitch cone, so the pitch radius changes along the tooth. Work at the tooth midpoint, where the mean pitch radius lives. The tangential load is the torque divided by that mean radius. The resultant force again has 3 components: tangential, radial, and axial, and this time the pitch angle of the cone does the splitting. The radial force is the tangential times the tangent of the pressure angle times the cosine of the pitch angle. The axial thrust is the same, but with the sine of the pitch angle. So the cone angle decides how much of the load turns into thrust versus separation. Bevel gears. Solve the forces. The gear transmits 1600 at a mean pitch radius of 2, so the tangential load is torque over radius, 800. The radial component is the tangential times the tangent of the pressure angle times the cosine of the pitch angle, about 250. The axial thrust is the same product, but with the sine of the pitch angle, about 150. That axial force is once more the bearing thrust from Lesson 2. And notice the split. The pitch angle alone decides how the shared transverse load divides between radial and axial. Worm drives, big ratio in one stage. A worm is a screw meshing a wheel on crossed axes at a right angle. The velocity ratio comes from the tooth counts, gear teeth over worm starts. It also equals the gear diameter over the worm diameter times the tangent of the lead angle. But the diameters carry that tangent factor, so never use a bare diameter ratio. The gear pitch diameter is its tooth count times its circular pitch over pi. On the worm itself, the lead is the axial pitch times the number of starts, and the tangent of the lead angle is the lead over pi times the worm diameter. Because a worm has just 1, 2, or 4 starts, a single mesh can give a reduction of dozens. That is why worm drives are used for compact high reductions. Worm drives, ratio and efficiency. A double start worm meshing a 40-tooth wheel gives a velocity ratio of 40/2, or 20, from the tooth counts, not the diameters. The lead is the axial pitch times the number of starts, 1 inch, and the tangent of the lead angle is the lead over pi times the worm diameter, giving a lead angle of about 9 degrees. The efficiency when the worm drives the gear is cosine of the pressure angle minus friction times the tangent of the lead angle, over cosine plus friction times the cotangent, about 74% here. So the wheel turns once for every 20 worm turns, but roughly a quarter of the power is lost to sliding. Drop the lead angle far enough and the drive self-locks. The wheel can no longer backdrive the worm. The same friction versus lead angle trade you saw with the power screw in Lesson 3. Traps. 5 ways this bites. 1. There is now an axial thrust. Helical, bevel, and worm all push along the shaft. The spur habit of taking only tangential and radial misses it and undersizes the thrust bearing. 2. The worm ratio is teeth over starts, not a bare diameter ratio. The diameter form carries a tangent of lead angle factor. 3. Helium mixes 2 pressure angles. The radial force needs the transverse angle, while the total force set uses the normal angle. Pick the plane the formula names. 4. Bevel forces ride on the pitch angle, and the tangential load uses the mean radius, not the large end radius. 5. Worm efficiency is well below 100%, so the input torque a worm needs depends on that efficiency, not on the ratio alone. Quick recall. For helical gears, the pitch planes are linked by the cosine of the helix angle, and the pressure angles by the same cosine. The radial force uses the transverse angle. The axial thrust is the tangential times the tangent of the helix angle, and the total is the tangential over the 2 cosines. For bevel gears, the tangential load is torque over the mean radius, and the pitch angle splits it into radial and axial with the cosine and sine. For worm drives, the ratio is teeth over starts. The lead and lead angle come from the axial pitch and worm diameter, and the efficiency carries the friction. Golden rule: every one of these gears adds an axial thrust, and that thrust is the load the bearing from Lesson 2 must react. Next up, Lesson 7, Planetary Gear Trains. Every gear pair so far has fixed shaft centers. Let a gear orbit instead of just spinning, and the ratio math changes completely. Lesson 7 builds the sun, planet, ring, and carrier arm, and the driver and follower bookkeeping the handbook uses to get their speed ratios. Everything's at peprepengine.com. A cheat sheet, work solution, and a quiz attached here.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.